Hello guys, very welcome back. In this video we'll be learning about measurement of earthquake. Now the earthquake measurements, there are primarily three scales: intensity scale, magnitude scale and the moment magnitude scale. Now first we'll see intensity scale. Now intensity is proportional to the damage. This was the principal idea which Giuseppe Mercalli in 1905 used it to measure the magnitude of earthquake, right? Later on, he modified his own scale, and in 1931 he came up with giving a value to the earthquake. For example, if your book from the bookshelf fell, then you assign it a value, say earthquake of magnitude 2 or 3, right? So on and so forth up till Roman number 12 it's used, right? So after a modification, it became a close-ended scale. But the problem with intensity scale is that it is subjective. Let's see what this means. Subjective means, suppose area in Japan is highly dense in terms of population, and area somewhere in Tibet is not so dense, right? Hence, even earthquake of same magnitude in Tibet and Japan, the damage in Japan would be much higher. Hence, the earthquake in Japan would be of higher value as compared to Tibet, right? So this subjectivity leads to a drawback in intensity scale, that is, you can't compare. It's not good for comparative analysis, right? Other subjectivity would be that in the very same, if we consider earthquake in Japan, for example, the earthquake was in Osaka, the damage in Osaka would be of maximum, but the damage in Tokyo would be lesser because Tokyo is farther away from the epicenter, that is Osaka. And hence, again, as I said, since the damage would depend upon the population, would depend upon the soil, would depend upon the building design, closeness to the earthquake, so on and so forth. Hence, it's a very subjective, but still appreciable, since it was started, the measurement of earthquake started, and to still some extent this Mercalli scale is still used. If we see magnitude scale, Richter in 1935 came up with the idea of that the greater the movement of the Richter scale, that is the ground shaking, the greater is the earthquake, right? And finally he put all this in a log scale, and hence, as we know, in log scale the amplitude of the previous, compared to the previous earthquake, the amplitude will be the 10 times and the energy would be the 32 times the previous. So log 5 and log 6, log 6 would have 32 times more energy as compared to log 5, and the amplitude of log 6 would be 10 times the amplitude of log 5, right? It's an open-ended scale. Again, the problem of subjectivity was solved and it became an objective. The problem with Richter magnitude scale is that it failed to measure earthquake which are very, very large. The reason is that the earthquake which are very large have large fault plane. The large fault plane leads to energy being dissipated at a larger area, and hence if you measure energy only at a smaller area, an earthquake would be underestimated. And this was seen when earthquake in Chile of 9.1 magnitude according to the modern scale was underestimated with Richter scale somewhere around 7, right? And hence, in order to remove this drawback, came the moment magnitude scale, The intensity is based upon moment magnitude. The scale came up roughly in 1979. The moment magnitude scale, it takes into account the rupture area, it takes into account the amount of rock displacement and the geological property of the rock. Right? So that's the three scale. Let's summarize. Intensity scale, right? Then we studied the magnitude scale, and finally the moment magnitude scale. That's all. Thank you.